So we know how to add, subtract, multiply, and divide numbers, but are those rules the same when we're dealing with expressions involving variables as well? Okay, that's kind of what we're going to get into with this video. So first off, let's lay down some vocabulary here. Okay, so when I say expression in math, I'm talking about some group of numbers, symbols, variables that represent something that we're doing. So in this one I'll write it a little bigger so you can see it. 5x minus 3. This whole thing is an expression, right? We call the individual pieces terms, right? We call the x the variable. This 3 over here is a constant, and anything that we're multiplying by the variable we call a coefficient. Okay? Individually these are terms. As a whole, this is an expression. Okay? So something you'll notice is a symbol that we're not going to use with expressions is an equal sign. Okay? If I put two things on opposite sides of an equal sign, then I'm dealing with an equation. Okay? So an expression, we have a few things, we don't have any equal signs. An equation, if I said 5x minus 3 equals 7x plus 4, now we're dealing with an equation, right? We have two expressions, we set them equal to each other. Okay? Mathematicians like to get a little bit fancy with their language. So we're going to call any expression with one term, we're going to call that a monomial. Okay? And that comes from mono, which means one. Okay? And I guess this suffix at the end means term, something like that. So if monomial is one term, then polynomial, or poly, which means many, right, is an expression with more than one term. Okay, so using some context clues here, we can determine that a binomial must have two terms. Okay, so something like x squared plus 1, or 2y minus 5, right, etc. Right? A trinomial, then, 3 terms. And most of the things that we're really going to specialize in understanding and breaking down are usually going to be in the form of binomials or trinomials, right? But all of them are polynomials, any expression with more than one term. Okay, so trinomial, I don't know, x squared plus 4x plus 2, right? There's a polynomial with 3 terms. Okay, something to keep in mind here, when we talk about combining like terms, something to remember is that we can only add and subtract terms that have the same exact variable and exponent combo. So if I had something like 5ab plus 7ab, that's 12ab, because both of these have an ab. However, if we had something like, I don't know, 4x plus 3x squared, okay, this is something that we can't do anything else with. Okay, we can't simplify this. That's as far as we can take it. Okay. Now let's suppose I have this expression here, 5x squared plus 9x plus 12. So take a minute, see if you can do this. I want you to list all the terms individually, and then we'll list their coefficients, their constants, and the like terms that can combine. So let's see, we have everything separated by plus, minus, those are going to be our individual terms. 9x, 12. Now this is a minus, so can we say minus 3x squared or negative 3x? Let's just say 3x squared. 5x and 4. Okay, so what are our coefficients? Well, remember the coefficient is the number that's multiplying by the variable. So we have a 5, we have a 9. Is 12 a coefficient? No, because it's all by itself. It's a constant. Okay, then 3 and 5 again, which leaves us with negative 4 down here, or 4, as our constant. Okay, so our like terms. Now, let's see, what do we have in common? We have a 5x squared. We have 3x squared. And if we were to combine them, now this minus sign, because it's going to come with the 3x squared, I'm going to go ahead and I'm going to put a minus in front of my 3x squared. Okay, so 5x squared minus 3x squared gives us 2x squared if we were to combine all our like terms here. What else? I'm going to cross these out as I go. So I did that. I did that. Now we have 9x and 5x, and we're adding them. So add their coefficients, 14x. And our like terms here, let's see, 12. And you know what? Just like before, I'm going to put that negative sign in front of the 4. So we have negative 4. So 12 minus 4 equals 8. So if we were to simplify this whole thing, we could write it as 2x squared plus 14x plus 8. Pretty cool. So why don't you go ahead, take a minute, pause the video. I want you to try simplifying each expression by combining the like terms. And if this last one is kind of hard to see, let me write it a little bit bigger for you. All right, so go ahead and pause. Try these. Okay, let's see. So my like terms, I'm going to, some teachers will say, circle them or put the same shape around them, so put boxes around the ends and circles around everything else. That gets a little bit crowded in my opinion. So I'm just going to kind of underline or color code the different pieces. So here's my 21n plus 1n. So I have 22n. And then 15 minus 2 is 13 plus 13. Okay. Something to keep in mind is that distributive property. Right? We have to multiply this 2 to both terms, and we have to include the negative. We cannot forget that, right? We can't forget that negative. So I have negative 2 times negative 4, and negative 2 times 3x plus x. Okay, let's keep going. Negative 8 minus 6x plus sometimes, I like to put a 1 in front of the x to remind myself that it has that invisible coefficient there. Okay, so what can we combine? Well, we can combine the negative 6x and the 1x. So I have negative 8, negative 6 plus 1, negative 5x. Okay, last one. Might be a little tricky here. We have a bunch of fractions and some decimals too. I don't know. I think maybe it would be easier to put everything in the same form. And this is going to be a personal choice for you. Do you want to put everything as a fraction, or do you want to put everything as a decimal? Okay. I'm going to convert everything to a decimal and then change it back to a fraction later because I can. All right, so I know that 1/2 is 0.5, so I have 0. Oh, that's a little big. So I have 0.5 x plus, I'm going to type 1/8 in my calculator, and that gives me 0.125 y plus 3/4, 3/4 is 75 cents, so 0.75x minus 0.25 y, and then we have this plus 1.5 at the end. All right, now that everything is in the same form, it's going to be a lot easier to combine. So let's see what we can do here. We have a 0.5x, we have a y, those won't go together. 0.75x, that'll go. So I have 0.5 plus 0.75, 1.25 x plus, let's add the y's, 0.125 minus 0.25. Ooh, that might be kind of challenging if you're trying to do it in your head. Try to do it in your head, that's fine. Or use a calculator, either way, I don't care. It should turn out to negative 0.125 y. So we took care of all of those, and now I have a 1.5 out here. Now, I don't know about you guys, but plus and negative looks a little bit sloppy to me. So I'm going to clean it up as 1.25x minus 0.125 y plus 1.5. That's it. So a few things to keep in mind here when we're adding and subtracting polynomials. Don't forget, deal with your parentheses first. Okay, if you're trying to convert something from a written phrase into some sort of expression, keep in mind that you should be using parentheses to separate the different expressions. Okay, and then deal with order of operations and all that. We got to remember to distribute negatives. That's really, really important. Okay, we got to remember that. That last one, that -2 times whatever times 4 plus 3x, right? How we distributed the negative as well as the 2. Okay, super important. All right, something else that you've probably talked about in like 8th grade or whatnot is when you're translating from written to, from words to numerical expressions, the from and less than can be a little confusing. They indicate subtraction, but we have to swap, right? So when I see the phrase 9 less than 7, that means I have to write it as 7 minus 9, or -2. Okay. Same as this 2d squared. Now I'm going to put parentheses around this. Okay, so take 2d squared minus 7d plus 6 from this. So I have 3d squared. And you know what? We're going to need to do this down below. Let's do this down here. So we're going to swap. So 3d squared plus 8d minus 2. And we're going to subtract 2d squared minus 7d plus 6 from it. And I'm writing this vertically because, these actually all line up, and this helps me distribute my negative. You can do it this way if you want. If you want to write it all on one line, you can do that too. Okay, either way. So one thing to remember, we got to distribute the negative, right? So this negative is going to go to all three terms. So minus 2d squared. Minus minus becomes plus 7d. Minus positive 6, minus 6. Okay. So if we combine our like terms, and you might see why doing this vertically is a little nicer, 3d squared minus 2d squared is 1d squared. 8d plus 7d minus a negative becomes 15d. Okay, and then negative 2 minus 6, negative 2 minus 6, negative 8. So either way you do it, you know, vertical or horizontal, gets you there. Right? You can try this one on your own. All we would do is put a plus sign in between them, take away the parentheses, combine like terms. Here's a really, really important piece of vocab here. When I talk about the degree of a polynomial, what I mean by that is, you know, if you look at the polynomial, it's the highest exponent that you can see. So for example, if, you know, we had something like x cubed minus x squared plus 100x, I would say this is a third degree polynomial, because 3 is its highest exponent. But what if you have, you know, something with multiple variables? What if you had, I don't know, x squared, y cubed, z minus 10xy to the fourth plus x z to the fifth. We'll do z to the third. Okay. What would be the degree of this? You know, I have a fourth degree here, but I also have a bunch of variables all with exponents being combined. So what we do when we have multiple variables, okay, is we're going to add their exponents for the degree. So I'm going to look for, let's see, each term. So this is 2 plus 3 plus 1, that is 6. Let's see, 1 plus 4 is 5. 1 plus 3 is 4. So this would be a 6th degree polynomial. We look for the term whose exponents add to the biggest number. In this case, it was the first term. It's not always the first term, but you know, it's a lot easier to deal with when we write it that way. Okay, last thing and then we're done. Multiplying monomials. Really, really straightforward. So when we say monomial, remember that's one term in the expression. Okay. So, you know, suppose I had like 5xy times 3x squared. What would the result be? Okay, I'm going to multiply their coefficients. So 5 times 3, 15. Now, instead of, you know, thinking of any rules yet, I'm going to write out, here's x, y, and then x squared. I know x squared I can write as x times x, right? And when I multiply, I'm allowed to change the order in which I multiply things. So let's put all these x's together. How could I rewrite x times x times x? Well, I could rewrite that as x cubed. So 15x cubed y. Now, what's the shortcut here? Whenever we multiply these monomials together, we're going to keep their variables and we're going to add their exponents. So I had x to the 1 here and x squared here. All right. To look at another example, let's suppose I had, I don't know, 4a squared times 3a to the 5th. We're going to multiply the coefficients. 4 times 3 is 12. We'll add the exponents. 2 plus 5. Well, 2 plus 5 is 7, so a to the 7th. Now, nobody ever said your exponents had to be positive. So what if you have negative exponents? Well, let's see. When we have negative exponents, and this is something that you talked about, I believe in 8th grade, x to the negative 2, right? What that means is you're going to think of this as a fraction, and when you have a negative exponent, that means whatever your base is, it has to flip to the other side of the fraction. So if you had a negative exponent on the bottom, that means that it goes up to the top and becomes positive. So if I had something, for example, let's suppose we had 3x to the negative 5 y squared times, let's do 9 x cubed. Well, we'll keep it a little simple. Let's do x to the 8th, or yeah, x to the 8th y. So I'm going to multiply my coefficients. 3 times 9. Now I could think of adding these exponents like this. Negative 5 plus 8. Remember, this is a 1 right here. In this case, we end up negative 5 plus 8 is positive, so we end up with a positive result. Right? Let's look at an example where you don't get a positive exponent and you have to flip it. So suppose we had z to the 2nd power times z to the negative 10th power. All right, my exponent rules say I need to add these exponents. So 2 minus 10 plus negative 10, which is negative 8. Because I'm left with a negative exponent in the answer, I have to flip it, change it to 1 over z to the 8th. And that's it.